Hi there, it's Miss Potts, and today we're going to be focusing on working with rational numbers. So let's take a moment and look at the focus. Our focus for today's lesson is to use least common denominators, decimals, and number lines to compare and order rational numbers. The questions that you should be able to answer by the end of today's lesson is, how do you compare two rational numbers when the denominators are alike? And how do you compare two rational numbers when the denominators are different? So keep in mind that these questions should be able to be answered by the end of the lesson. Before we get started, let's take some time to review some basics before we move forward. I want to make sure that we all have a strong understanding of what this is. This as a whole right here could be called a fraction or a ratio. And this top number, I don't want to refer to it as the top number. We're going to use our mathematical terms and call it our numerator. And our bottom value is always going to be called our denominator. So please take a moment to make sure that you have that written down somewhere so that you can remember that when working with fractions, that the top value is always called the numerator and the bottom value is always called the denominator. Since we're going to be comparing and ordering rational numbers, I want to take a moment to review the symbols of inequality and equality. When we compare our rational numbers, we're more than likely either going to say that one is greater than or one is less than the other. So I want to make sure that we all understand that greater than is pointing to the right with the bigger part open to the left. And less than is pointing to the left. One way that I always remember that is that it makes an L, almost. If you would tilt it to the side, it would almost look like an L for less than. That's just one way that it helps me to remember the difference between my inequality symbols. This is also a quick overview for you guys to know. You can compare rational numbers by finding a common denominator. So the denominator of all of the fractions needs to be the same. And then you can compare the numerators. Because keep in mind, what we do to the bottom, what we do to the denominator, we have to do to our numerator, the top value. So having a common denominator is any common multiple of two denominators. So let's move on to talking about a least common multiple and a least common denominator. Least common multiple is of two numbers, it is the smallest number that is a multiple of both numbers. So if you take a look at this example down below, we're asked to find the least common multiple of 15 and 6. We list out the multiples of 15, 30, 45, 60, and it could keep going. So in other words, we're skip counting to whatever value we're provided. So 15 plus 15 is 30, 30 plus 15 is 45, 45 plus 15 is 60, and so on and so forth. And so then we do that for whatever other value we have, we need to solve for that multiple. So we then find the multiples of 6. 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 6 is 24. 24 plus 6 is 30. And we have the value now listed that's the smallest multiple of both numbers. So there we have the LCM of 30. So you've learned what the LCM is, the least common multiple. Now it's time to take a look at what a least common denominator is. The least common denominator, or LCD, of two or more fractions is the least common multiple of their denominators. So that's why it's very important for us to be able to know how to solve for the least common multiple. It's the same concept as the least common denominator, but we're solving for the least common multiple of the denominators. So take a look at this example. The least common denominator of 3/8 and 7/10 is 40, because we are finding all of the multiples of our denominator and figuring out what the least common multiple would be. So in this example, all of the multiples of 8 are listed out. 8 plus 8 is 16, 16 plus 8 is 24, so on and so forth. And so then we are able to recognize which value, which multiples do they have in common that are the smallest. We're going to be solving for the least common multiple and least common denominator in order to compare and order fractions. So let's take a look at an example of what that is. In this example, we are asked to compare using a least common denominator. We need to figure out which is greater, 4/9 or 5/5. We first need to start by figuring out what the least common multiple is of 9 and of 12, because we are finding a least common denominator. But in order to do that, we need to find a least common multiple first. So let's list out the multiples of 9. We have 9, and then we have 9 plus 9 is 18. 18 plus 9 is 27. 27 plus 9 is 36. 36 plus 9 is 45, and so on and so forth. Another way to think about this is 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. And 5 times 9 is 45. Let's start now by listing out the multiples of 12. We have 1 times 12 is 12. 2 times 12 is 24. And 3 times 12 is 36. And I can stop there because I see that both of our values have a common multiple, and the lowest is 36. So I'm going to write that up here. Now that's just the first step. The second step is to now write equivalent fractions, 4/9 and 5/12 with the least common denominator of 36. In order to do that, we have 4/9, and we need to set that to have a denominator of 36. And the same thing with 5/12, we need to set our denominator to 36 so that we can compare our numerators to figure out which one is greater. So let's take a look at where we multiplied by different numbers to figure out what our multiples are. What times 9 equals 36? I'm going to look right here. 9 times 4 equals 36. And what we do to our denominator, we also have to do to our numerator. So let's multiply our numerator by 4 as well. 4 times 4 is 16. So our equivalent fraction for 4/9 with a least common denominator is 16 over 36. Now let's do the same for 5/12. What number times 12 equals 36? We take a look here, it's 3. 12 times 3 equals 36. What we do to our denominator, we also do to our numerator. So let's multiply 5 times 3, which equals 15. So then we write here, our equivalent fraction of 5/12 with the least common denominator of 36 is 15 over 36. Our question is, which is greater? Now that we have a least common denominator, we can compare our numerators to see that this fraction is greater than this one. So in other words, 4/9 is the greater fraction. We can also use our inequality symbol by writing this. 16 over 36 is greater than 15 over 36. Now we're going to switch gears to moving on to ordering rational numbers. And here's our example. We have a mixture of fractions, decimals, and we're dealing with negatives here. What we need to do is we need to apply knowledge from previous lessons to change this fraction and this fraction into a decimal so that we're consistent throughout. So what I would do is divide 5 by 8. 5 divided by 8 then equals 0.625. So I'm going to write that 0.625. I'm going to drop down my other value, which is 0, negative 0.37. I'm going to drop down my 1. When we when we divide 29 by 40, that equals negative 0.725. And then my last value is 0.3. Now I'm left to order them on my number line. What I'm going to do right now is we have 0.625. And that's positive, so I'm going to be looking over here. I know that we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and it's a little bit more than 0.6. So I'm going to write that down below, 0.625, and I'm going to put a check mark below it, knowing that I have plotted that on my number line. Next, we're working with a negative value, so I know we're going to be working to the left of 0. I have negative 0.1, negative 0.2, negative 0.3. And it's closer to negative 0.4 than it is to negative 0.3, so I'm going to mark that right here and write that down below on my number line. Negative 0.37, put a check mark. Oh, look, we have a whole number of 1, so let's go ahead and plot that and check that off. Our next value that we need to order is negative 0.725. So we're working to the left of the 0. We have negative 0.1, negative 0.2, negative 0.3, negative 0.4, negative 0.5, negative 0.6, negative 0.7. And it's shortly after negative 0.7 where we can plot that point and identify what that is. 0.725. And last but not least, we have 0.3, which is to the right of our 0, negative 0.1, 0.1, 0.2, 0.3 is right here on our number line, 0.3. So in having all of these rational numbers, we then changed our fractions to represent decimals so that we all have them in the same form, and then ordered them from least to greatest. Now it's a point in the lesson where we're going to review, and I'm going to ask you those questions that I presented at the beginning of the lesson. How do you compare two rational numbers when the denominators are alike? And how do you compare two rational numbers when the denominators are different? Ask yourself that question. If you aren't able to answer that question, please go back and review this lesson. As always, if you have any questions, please don't hesitate to let me know and get a hold of me whenever you can. Please take some time to answer the questions below to demonstrate that you understand how to order and compare rational numbers. And don't forget to complete your assignment. See you guys in class.